Hey guys, how's it going? Welcome to another episode of Ferris Makes Demos. This is episode 37, and I called it Bloom Play. So I knew that today I kind of wanted an easy day, but I also didn't want to take today off because I took Thursday off. A couple things. I also tried working out for the first time in a little too long, like a couple hours ago. So I am really... I'm in a great mood, let's be honest, but I'm finding it hard to focus, so I need kind of an easy day today. Anyway, I haven't really streamed actually sitting down with our demo tool and making stuff for a while. And part of that is because I haven't actually sat down in the demo tool and made stuff for a while, except the stuff we did around Evoke and around just before revision. Except I did do a couple experiments recently, and I had some chats with a couple guys, including Kuzma of Excess, who was telling me about the way that they did the bloom in their demo Aurora from revision. So if you guys don't know what bloom is, it's the effect here where you have some really bright things on the screen and then you get this like halo-y effect around them. So the light kind of leaks towards neighboring pixels. In an image like this is from our demo Engage. And the reason why I'm looking at this image in particular is a couple things. First of all, the bloom does a lot in this scene. If I take it out, which I think I can just do in my sync tracker here, should have a bloom amount, yeah, here. If I turn this to 0, this is without bloom. So you can see the bloom really does a lot, especially for making these areas that are emissive actually look a lot brighter than the things that are around them. So this is what it looks like again with just that. Let me see if I can actually show you guys what it looks like with just the bloom. Move stuff around here. I think I have to actually change the shader, but that's fine. Should be a composite shader here. I'll actually pull this up. Did I just call it composite pass? I probably did, yeah. Need to clean up some of this stuff, but that's fine. Let's just do the bloom color here. I'll comment this out. Let me bump up the font size for you as well. And I'm actually going to move this so we can see when I change this. So that's just the bloom. So as you can see, it does a lot. But one of the things about this bloom is it actually, it helps a lot in this scene, but I actually am not super happy about how it looks, and I never really have been. The main reason is that the fall off of this, like, when you have bloom, you have these really bright stuff, and then it kind of falls off into, the not as bright stuff. And that curve in which it does that, in this case, is a bit too Gaussian. So it just looks a bit too soft, I think, that fall. It looks a bit too round. Like if I pull up paint here, like it looks a bit too much like this kind of shape, this kind of bell, right? So you'd have the really bright stuff here, and it has this fall off where it's a pretty smooth transition of the slopes before it actually goes down here. Ideally, we would actually, I think, have something more exponential looking like this. So you'd still, oops, that's really drawn really poorly, right? So this is what we don't want, but this is what we get due to the way that we do the blurs. And then this is what we do want, I think. So the reason why it looks really Gaussian is because the way that we implement this is, let's see, I don't remember the exact details of how many blurs I use here. But the idea, in fact, I can actually show you guys exactly what we do in Photoshop because it's fairly easy. So we take the original image. I actually need to take this without the bloom. So I'll go and turn the bloom off again, and then we'll take a new screenshot here. And this won't be exactly like what we do. It won't turn out to be exactly the same because in Photoshop we're working with sRGB. So when we do our composites, I don't think it'll be linear. But also there's some extra post-processing happening after the bloom, which we'll lose here. So we won't get exactly the same result, but this will be more than enough to show you guys basically how this is done. So, whoops, there we go. So this is basically, we'll call this the dry image. And what I'm going to do is I'm going to duplicate this layer. And what we're going to do is we're going to take this other layer here, and I'm going to do some adjustments on it. The main thing I'm going to do is I'm going to take like brightness and contrast. I'm going to turn the brightness down a bit. And the reason is because we want to separate some of the things that we want to glow from the things we don't want to glow. So that's just really easy to do. Though I'm also going to bump up the contrast just to isolate those even more, right? So we've gone from this to this, and we're just trying to isolate the bright parts. Once we've done that, we're going to do a couple things here. Normally, we would actually downscale this at this point. That's what we actually do in the demo because we're going to do some really wide blurs, and we're going to get basically the same effect if we do a less wide blur on a smaller image than if we do a really wide blur on a larger image, and that'll make it a lot faster. But because this is Photoshop and the way that I'm going to do this, it's easier if I just do the blur here. So if I remember, this is under filter blur, and we want a Gaussian blur. And then we just have a really wide Gaussian. I'm actually going to do a little bit more brightness contrast here, just to bring out the brights even more. Like here, do something like this, just to really isolate those. Again, the point being that it tries to isolate the bright parts first, and then it's going to do a kind of Gaussian blur. And the Gaussian blur, as you can see, has that same kind of soft fall off that we actually have in the demo. And once we have that, then we just additive blend that on top, right? So now we have width, without, and width. So it doesn't match exactly. In fact, I'm going to do a bit more here to just bring this out a little more, but you get the idea, right? Like this is, we get something close to this. So that's basically all we're doing. And as you can see here, because we also used a Gaussian blur, we have the same kind of bell-shaped fall-off that we get here. There's a couple ways to fix this. The way that they fix it in one of the demos from Revision this year, which is called Aurora by Excess, is they actually, as they're doing the Gaussian blurs, so you can imagine, let me pull up Paint again. So I take basically the main image with some stuff in it, and then I downscale a bunch of times, right? So I get a smaller image. And then I blur that image. I get like a fuzzy circle. And then I do a composite with this and this image to get the final image, which has the bloom on it. Right? So this is what we do. What they do in this other demo, which I want to watch in a second, is they take the original image, and as they downscale it several times. And what mine does is it basically discards these intermediate ones here, because it only needs them to calculate this image here. So these we just get rid of. But what they do is they actually do a couple downscale steps. And also we do a couple downscale steps as well. But that's more to make it, fast and accurate rather than to do something else. But anyway, at every step when they downscale, they blur it a little bit, right? And so you get sort of these compound blurs here that are really nice. By the time you get the smallest one, you have a really, really wide blur. And then what they do is instead of just compositing the original and the final one, they composite all of them with different weights. And what you get is also the image with bloom. But again, here we have this sort of bell curve fall off, which has to do with just doing the Gaussians at this level. Whereas by mixing these different blurs of different resolutions, you'll get sort of a sharper kind of fall off here, which should look a bit more natural. That's kind of the idea. I might actually want to do this as an experiment in Photoshop again, just to kind of compare the two. But actually, did I just close Photoshop? Yeah, I actually don't want to do it again. So we'll just have the original to compare with. I'll take a screenshot and then we'll start that. So I'm actually going to take screenshots of all this. We want the dry one here. I'm just going to save this here. And then we want the original. and then we'll get another screenshot when we actually implement this other one. So if I recall correctly, you guys may not be able to see this very well, but let's just dock this up here. We don't actually need the preview. So this is the rendering pipeline basically for Engage. It's actually a little bit different, and I do want to talk about that. But actually, before we dig into this, let's go ahead and watch that Access demo. I'm just going to pull up the YouTube for that. So I'll link the Poet demo here first. Is there something wrong with chat? Because I'm not seeing anything, by the way. And it just said, welcome to the chat room. I'm going to refresh my Twitch here, or my dashboard. That's also why I haven't said hi to guys in the chat, because I haven't seen anything here. So let me link this. Oh, Una Noctium. There we go. Test message. Yeah, that works. Hey, Arthur Carlson. Okay, so now my chat's working. Sorry about that. Yeah, comma. All the jokes have been lost. I should have mentioned that earlier, but wasn't really thinking much about it. Anyway, this is a really cool demo. So let's just go ahead and watch this. I'm going to need to unmute my stuff first here, too. Up and I'll mute me as well. So yeah, really cool demo. I'm a big fan of this. Just simple, straightforward style. Nice effects. And I believe this is open source. In fact, I know it is. It is written in Vulkan. You can get the source here. This is the actual link just from the Poet thing. We want to look at this repo, the Even Laster engine, which is the successor to the very last engine ever. And I think when I was looking at this the other day, I thought there were different branches in here. But maybe I'm full of crap. Because I can't remember where I found it. But I was looking at the Bloom code. It's not here. And wasn't there more branches? I hope Eric didn't delete the branches within like the last day, because I had this pulled up on my phone like yesterday. Yeah, I guess I can view the code at this commit as well. That should work. Good enough. Okay, at least we have a lot more files here. Here we go. So there's two things here. There's the bloom upscale and the bloom. And if I recall correctly, the bloom, this is being used during these downscale passes, and it's doing some kind of diagonal offsets here to probably take advantage of some of the filtering as it's doing the downscaling. If I understand this correctly. Yeah, it's definitely what's going on here. And then the upscale, this one is where it actually combines all of the different levels of the blur with some weighting, and then we get the actual nicer bloom. I don't plan on porting this exactly. I plan on just kind of taking the general idea and just seeing what happens today. So we'll figure that out. Now I haven't actually looked at any of the CPU side code to make this happen. I'm guessing just off the top that this is probably, it's either in swap chain, unless this is a more general thing. Again, I'm not very familiar with this code, so we're just going to have to dig. Yeah, I think this is more general code. Then maybe it's in main. That'll at least tell us where things are. In fact, actually, we can search for bloom. Yeah, so there's a bloom render target, bloom upscale target. Several levels here. If I search bloom render target, I should see where this is. Yeah, so here we go, different MIP levels for the different levels of the bloom. Like, this is still probably some setup stuff. Just creates the image. If I remember correctly, he's also doing like different images attached to the same texture here for the storage. I think that just made it more convenient. Sorry about the rumbling if you guys are hearing the asshat with the motorcycle outside, by the way. Create full screen quad pipeline with this stuff. Yeah. Now, I'm not that familiar with Vulkan or this code. So I'm not entirely sure how this fits together yet. Yes, that's exactly at Studio C. I feel like I explained that earlier, but I don't know if you were here because I didn't see the chat. So if you want more explanation, I drew this diagram. Yeah, the text size is small when I'm looking at GitHub. Sorry about that. But I was just trying to look at it more. Or see more of it at once as I was just gleaning it. Because to be honest, the code in his demo is not very important for what I want to do today. It's just what I'm looking at as sort of a reference. So Sorry about the fonts. I'm actually going to bump it up a little smaller than I know you guys really want, but it's going to make it easier for me just to see what's going on here. But I think all that's happening here, because he has the pipeline layout, and I guess this is describing a pipeline for the things that happen for the bloom. And then, yeah, there's also the bloom fragment shader. Yeah, no, here's the pipeline. It's pipeline layout. Again, not entirely sure how those pieces fit together, but I guess the bloom pipeline... PK command pipeline for the command buffer. Okay, yeah, so he's making the command buffer here that includes running this bloom pipeline, I guess. And inserting, yeah, draw commands here. So this command buffer and enter pass there. Okay. But yeah, this makes sense to me. For all these different bloom levels, he's doing a downscale draw, and then finally he does the upscale at the end. But all of this is doing... I don't even think this is per frame. It might be, though. No, it is. Well, you shouldn't close the window. So every frame he's just building the command list here. A bit indirect. I'm not used to Vulkan, but that's what it makes sense. That's what makes sense here. Different barriers and the different post-processing render targets. And then, yeah, at the very end, he submits everything. I'm guessing there's just this one command queue that he does for every frame. That would make the most sense in a relatively straightforward demo like this. Yeah, modern art with Ferris. So I think what I described down here is basically exactly what's happening. Doing different Gaussian or doing different blurs, a bunch of downscales and blurs at the same time, and then compositing all of them back together with different weights, so we get ideally a better curve, a better fall off or more natural fall off curve than what we get here. And the weights there, by the way, work somewhat interesting. If we look at this bloom scale pass, it seemed like there was this shape thing here. So for each level, the weight of that, it just took I to the power of this value here, of this shape value. And I guess the shape would ideally be something like between 0 or 1. Just trying to figure out how that would match up. Because the I here is the actual level itself. I think that makes sense. Not really sure. Anyway, just as a weighted sum of all these. So we're going to want to play with that. But I'll probably parameterize that myself and play with it here. But I think this looks relatively straightforward to sort of massage the bloom that I have into this. The font size in the tool I can't increase, so you guys are going to have to live with that. But I just need to look at what we're doing so far. Because I'm pretty sure that all I do is 3 simple downscales. So that means we're actually going to do the blur in 8th res. And then after those downscales, I do some ping-pong separable Gaussian blurs. And I guess if I wanted mine to match theirs the most, the way I would probably do that is after every downscale, I do a couple passes through this ping-pong blur. I actually do 7 of these ping-pong blurs down here at the lowest level. It wouldn't need to be that many if we're doing Gaussian blurs at each step. But yeah, so we're still going to do Gaussian blurs as we downscale. I think that I'll just do these separable ones at each stage here with the different render targets. I think. So let's see here. I'm going to move stuff around here in the tool. You guys won't be able to see everything, unfortunately, but I'm going to need to just sit here and massage these blocks. So I'm just going to dig in, I think, and at least hopefully describe kind of what I'm doing. So the way I have this set up, I don't want to go too much into detail about how the tool itself works. I've done that a lot in other streams. But the idea is that these different blocks are actually like imperative, like stacks of imperative code. You can kind of think of them that way. So like this initializes all the render targets, and then there's different passes that the actual pipeline is doing. Particularly the bloom pass here. Some of these I just fan out into other things down here. So like there's some stuff for the indirect illumination. This is all the depth of field stuff, and then the bloom stuff is all down here, except of course the render targets, which are up here. So I think we have some bloom blur targets, and those are of course 8th res because we downscale 3 times, so divided by 2, divided by 4, divided by 8. I think I'll still do that many levels. I don't think we'll need more than that, but maybe we will. I mean, we'll just have to see. And I'm just going to end up making a lot of these targets by hand. So now for every downscale, basically, we're going to do a blur. We're not going to need it for the highest res because we don't really need that. So let's see. We also need 2 blur targets per downscale level. So let's just do... How do I have this set up? The first downscale target is, half width, and the second one is 4th width, and then there isn't a 3rd downscale target because I think the 3rd downscale just renders straight into the bloom target. That would make the most sense. So the way I would do this actually is to remove these downscale targets altogether, and then duplicate these blur targets. See, when I remove those, I get red stuff down here because the render target that this refers to doesn't exist anymore. So I'm actually going to copy these other blur targets here. So these blur targets, like they're 1 and 2. I'm actually going to make these 1, 1, 2, 1, 2, 2, 1, 2, 2, 3, 1, and 3, 2. These are going to be 8th res. These ones are going to be 1/4 res. Kind of annoying to do this by hand, but at least it'll be done. A way to do it. So we no longer have the downscale targets. We just have blur targets. And this should be relatively straightforward because I have copy paste. It would have been more annoying without that. I think blur here. Yeah, we're going to adjust some stuff here, but in fact, I'm actually going to take this bloom pass down here while we work on it. Yeah, so here we want to do the bloom blur target 1, 1. That's what we want to render there too, and then we're going to do the second downscale to 2, 1, and we'll do the final scale down to 3, 1. And these existing ones, if we want to keep those the same, this is going to be 3, 2, and 3, 1 that it bounces back before. We'll just do the 2, I think. So yeah, the first downscale as input takes this composite target, and as output goes to this bloom blur target 1. And then we're going to do this stuff. I think I'm going to get rid of this blur pass here. We're actually going to copy that as well. We don't also need to repeat this 7 times. Basically be this. So between all the downscales, we have a blur pass. And the blur pass itself, we're going to fan out here. So it's going to be a lot of copy paste to just get this working, and then I can probably refactor it later, but I think this is the right way to just move with this. Just copy all this out. And then we're going to make all this line up with the different targets. It'll basically be that. Call this 1. Blur step 1, 1. Blur step 2, 1, 1, 2. Actually, these are going to be over here. And then we'll copy these ones. Blur pass 2. Step 2, 1, step 2, 2. A lot of this is actually duplicated a bit because I still don't have a way to, I don't need to explain everything. The reason I have 2 blur steps is because we do, whoops. Don't click there. The reason we have 2 blur steps for every blur is because we do a separable Gaussian, so we do a horizontal and then a vertical blur. In this case, we could probably do it all as one pass like they did in the XS demo, but I'd rather just massage the code to get to where we want first instead of rewriting too much stuff just for my own laziness. One, 2, 3 in here, and then the blur passes we'll do 1, 2, and 3. And then we gotta line up all the textures. I think this will more or less just work, except when you fix all this stuff, I think we need to fix some buffer bindings up here at the end in our compositing. And then we should have basically the same thing, except it's probably gonna be wider. Yeah. Huge convolution kernel would also be fine. But yeah, probably be a lot slower. And I forgot to take some measurements of the speed before we did this, but this shouldn't be too bad. Oh, I'm also totally working out of the wrong project file, but I can just fork that out when I'm ready. So yeah, so these blur targets don't make sense anymore. We need 1, 2, and 1, 1. And oh, wait a second. Can I change that as 2 here? No. This is 1, 2, yeah. These are also wrong. Did I copy those wrong? I totally did. It should be 2, 1, and 2, 2 here. So this should be, we downscale to 1, 1, and then we use 1, 1 while we render to 1, 2. Yeah, and then here we render back to 1, 1 using 1, 2. That makes sense. Then we're going to downscale again using 1, 1. Because we're going to render back to 1, 1 here. Blue target 1, 1. In the second pass, we're rendering to 2, 2. Wait a minute. Yeah, because here we do the bloom target 2, 1, and we're going to render with blur target 1, 1 as the texture. Yes, this makes sense. So this will be 2, 1, 2, 2. And now we're getting errors up here due to the order in which things are compiled. Let's fix this here. This will be bloom blur targets 3, 1. Then I'll take the lowest one. And we'll switch these around just to test some stuff too. On the final downscale, we need 2 bloom blur targets 2, 1. Because that's what this one writes to. And then in the last one, we're going to downscale to bloom blur target 3, 1. And then we're going to use 3, 1 as the texture here, and then 3, 2 as the texture here. And now we got an image. I think I still have the, no, I don't. Okay, hold on. Jimbo, thanks for the follow. still need to make those for subs, but yeah. So this is where the fun begins. We should have gotten an image, but we didn't. So, okay, so my composite pass as a bloom texture uses bloom blur target 3-1. Bloom blur target 3-1 and 3-2 are 8th res. And that is what we got. Should have gotten from blur pass 3. So we downscale pass 1, blur pass 1, downscale pass 2, blur pass 2, and then a 3. Pass 1, blur step 1, 1, step 1, 2. Downscale pass 2. Okay, the names here all look good. 3-1, 3-2. And the texture we use here is 3-1, which is what we draw to when we downscale. That goes to 3-2 and then back to 3-1. So this, we should have an image here. So an easy way to start testing this. Also, the bloom is taking some time in the profiler. That's a good sign. So let's see if I can... There's always a challenge trying to fit stuff on screen so people can see what I'm doing, but we'll try. So we might actually be seeing some of this. I'm actually going to, just to test... No, adjust the bloom amount, and that doesn't help anything. So if we look at the bloom texture, let's say we just do the GI... Actually, what did I call it? The GI composite target. If we do that, then we should see a bunch of lightning because that's the input to the bloom, right? So that makes sense that that would be, that there's images on there. In fact, I'm actually going to adjust the composite path to just show the bloom again. Hey, G Superland. Right, so this is just the bloom, but it also does the adjustments of like the brightness and contrast stuff that I showed earlier in Photoshop. So that's if we just use the GI composite target with no downscale. So now we'll do the bloom blur target 1-1. Okay, and right away, it's the resolutions that are wrong because we just see some stuff down here. So I think that's going to be these values here, right? Because here our widths and our heights are wrong here because we downscale down to 2/2, and here it thinks the width is 1/8 res, which is wrong. We need half res here. I still don't think this looks quite right, but let me adjust the other part of the blur, and maybe that solves it. It didn't. Oh yeah, because we also have the width and height that are wrong here that need to match up. So I think we'll just adjust those. And that should have shown us something. This is not great. Just to be sure, these downscale, or these bloom targets are... That's not the right resolution for this one. Okay, that looks better. That's what we should see. So on the next step, so this is our first blur step. All comment says, editor improvement, show a preview of the content of a target when selected. Yes, that is on my list. For now, we got what we need. So now we'll do 2-1, and that should show us the next blur. And as you can see, more resolution problems. So we'll go ahead and adjust those as well. And I think that's just in the second blur. I just need to have the right resolutions and viewport sizes for everything. As you can see, this is lower res and blurrier, which is exactly what we want. And then finally, the last one should be 3-1, and then we have something pretty similar to what we had before. So this generally looks okay compared to what we had before, at least. So now if I go back and put everything back to normal, then we have this image. And this should look pretty close to what we had in the other one, because we haven't actually done anything differently with this. We've just done different blurs. You can see a little bit more of the upscaling stuff here now, because we didn't blur as many times, which should be fine. I might want to adjust that later, but I don't think we'll need to. So the next step in at least a really trivial implementation of this, like I've done here, I'll want to refactor this probably later, but at least to parameterize these and have it just call these as subroutines. But until then, we're going to ignore that, and we're just going to have the composite paths here take in multiple textures, because we need all 3 of these downscale targets, and perhaps even the original one as well, for the different bloom levels. And then it's going to actually mix all of those to make the actual bloom. So let's go ahead and do that now. So the bloom text, I'm actually going to turn this into bloom text 1, 2, 3, and 4. And this one will actually be the GI composite target here. And then here we're going to have the blur target 1, 1, 2, 1, and 3, 1. And that'll be enough for this. So then we go in the shader code. Let me adjust my window size again. And here we need the bloom text like this. And now I should start seeing some shader compile errors. And the issue is that it doesn't use bloom text right now. Or it still uses the name bloom text, but we need 1, 2, 3, or 4. As you can see, they get a lot wider when we do the different levels. So I just want to look at the bloom right now. I'm just going to look at this bloom color as output. And again, this is still going through other parts of the post-processing chain, and I don't really care about that. So again, here's our original image, but of course with the post-processing everything applied, because as you can see here, I've adjusted everything here. In fact, actually, I should be doing that before the downscales and the blurs when I really think about it. That's probably another improvement that we'll want to do, but I don't expect to get all this done today. I'm just expecting to play with this on stream, so that's fine. But yeah, we're going to want to mix these different colors. I think what I want to do is actually mix them all before passing them through the rest of this stuff, and that's just me probably being kind of lazy. So we can do bloom sum. It's going to be this. Now what I'm going to do is I'm going to lift some stuff from that excess code where I do shape, and we're going to call that 1. And what we want to do here, let's do this. Again, this is crappy without a loop, but it's going to be fine just the way that I'm doing this. We can just call this one plus 1. We'll take the pow of that to the shape. So we're just doing a weighted sum here. And the reason I'm not doing this in a loop, by the way, is because of the way that GLSL has a bunch of limits on how you can pass around samplers. So even if I did it in a loop, I would have to at least do all these samplers into an array and then do the weighted stuff in the loop, and I just don't care right now. So we'll do bloom sum divided equals weight sum. And that should be some kind of sum. Already, that curve looks really nice, by the way. So as an alternative, we can do this. This is basically kind of our baseline. And here you can see the fall off, rather than looking so billowy like this, actually looks a lot more natural, like the kind of curve we want. And then if we play with this shape, nothing happens. What? Ooh. Oh, first of all, I'm not adjusting the weights properly. Yeah, so if we increase this, we get something a lot closer to what we had. Interesting. So if we bring this back, the full composite, already I really like the fall off of this better. This is what it would be in full res here. I'll just get rid of the operators here. The other thing that I want to talk about here is speed of this whole thing. Oh, where'd my profiler go? There's my profiler. Dock, please. So our bloom now is still really fast, but the fall off definitely looks better here. Of course, not as wide, but that's fine. In fact, there's ways to get around that as well. If I actually make all these different blur things repeat a couple times, we'll get... This isn't a great way to do this, but... Need to find the repeat thing here. So it used to do 7 Gaussians. We do not want 7 Gaussians. We'll do like 2 at every level. And then speed-wise, we haven't really made this like any slower. What GPU do I have? I have a GTX 1070. That's exactly at Studio C. It's creating like a different ramp of the blur. So we're basically doing a bunch of Gaussians as we downsample. So in this bottom diagram, and then we do a weighted sum of all of them rather than just what I had before, which would be a bunch of downscales and then a blur and then only summing or compositing the original and this really blurred one. Here we composite all of them with different weights, which should give us at least a better ramp. And playing with this ramp function, like how all these different contribute. Layered weighted bell, that sounds exactly like what it is. But already I think that looks a bit better than what we had before. Again, this isn't an exact... Well, actually, I have the exact one over here. So this is the Gaussian one. Of course, here it was a lot wider. And these aren't exact one-to-one due to the positioning and the zoom, but... The fall off here is a bit more natural. And I want to play with that a little more, actually. The other thing that I would probably do here, actually, let me see this here. Yeah, the other thing is because we don't do as many blurs at the different levels, I could bring some of those back, actually, if I really wanted to. Because what I actually want to do here is get the really wide stuff anyway. We shouldn't need as many if I just add more passes. It's all so fast still. This is the bloom. It's still like 0 to 1 milliseconds. So we're good there. Because I still want it to be really wide. But I want it to have that better fall off. Like compared to these two, you still get, at least I feel like I get that sense of width in the bloom, but the fall off just looks so much better because this is so much of a bell curve here. And this really has a better fall off with the different weights. And I can sit here and play with this shape value here and get something in between, which is nice. Like here, you can see this is really, it feels kind of flat and then kind of tapers off. Here, it really has a nicer curve. I call this a success already. I'm probably going to tweak this more later, but at least in terms of what I wanted to do today, that actually is basically done now. Again, dry and wet. We can look at some other scenes with this as well. To see how this affected other things. Here, the fall off here, of course, is a lot different now. Again, as a rough comparison, we can see that this was the lowest bloom level, so it goes a little farther, but this again has a more natural fall off. Yeah, the other thing is with those downscaled passes is that you get, they're actually a lot faster themselves, just because you're blurring so much less area. In fact, I would probably, as I tweak this more, I'm probably going to do like 2 more passes, go down to 32 by 32. Because, oh, the curve here is so much nicer. Maybe it's not, but it really feels like it is. Yeah, this looks way better in this case. The way this falls off here. This was worth doing. Again, shout outs to the Excess crew, particularly Kuzma, who was talking about this at work one day. Because that's what inspired me to look at this. By the way, this isn't actually Engage. This is a modified version of Engage that's faster. Not much faster in this case, because most of Engage relies on secondary race for everything, including the rough surfaces. But I did an optimization that was based on the Looney's revision 8K, where I do a cone tracing pre-pass, which offsets all the primary rays. I can actually show you guys some of that, which is really cool. First thing I'm going to do, though... Actually, no, I'll fork this stuff after the stream, because that's boring. But how should I show this? I think what I did, I can just output some crap here. It's fine. Let's see. Let's go with the masking pass and replace the input to that. No, we'll actually just replace the very last texture. That'll be good enough. So here I have a pre-pass target, and let's adjust something else there too, because this is saturated. Where's my March pre-pass? Pre-pass epilogue here. Divide by fog distance. Does that do it? Nope. I gotta remember how I put this together. Okay, you actually do see it here. But I divided by the wrong value, I think. No, maybe I didn't. Let me see. Okay, this is what it should look like. So we are actually okay here. So what this is a debug view, and it's also a filtered debug view, so it's not perfect here. But what's actually going on here is I've separated all the ray marching into 2 passes. The first pass does a 1/8 resolution pre-pass where instead of just tracing primary rays, it just traces these cones, which are just wider rays. And the idea is that it basically shares primary rays between every 8x8 tile. The Looney's AK actually goes a step further with this, and it has a bit mask per tile that says which objects you even need to, like each object will even be considered by all the rays in that tile. I haven't gone that far with this optimization yet. I've just figured out basically how far you can go along the different rays in a pre-pass here, in this tiled pre-pass. And then all the actual tracing happens that's per pixel, but offset by this value contained in this buffer. So this is sort of the output of the pre-pass messed up a little bit, the way I showed it here. But the last thing I can do is I can do the regular stuff here. We'll do the gbuffer target. I think, yeah. Do this and then I'll output some more debug stuff and you'll see that this is kind of cool. The thing is that this didn't really speed up this demo so much because the object count per scene is fairly low. And again, a lot of the stuff has to do with the secondary rays and how we process those in order to make the whole look. So didn't see that much improvement, but there was enough that it's worth doing, especially because I was able to massage the code so that it's not that much worse to work with, which was really important in this case. Let me see, where's my... I'm just digging through code here to remember how to debug this or how to show the debug output, because I did this a few weeks ago. It's got to be in the March epilogue here, I think, because what I want to do is I want to see... I think the results here still have iterations. They get optimized away because I don't use them for anything. But we can output the amount of... Yeah, I do it here, actually. Does that work? Or did I output to the wrong buffer here? Direct illumination. Where's my gbuffer layout? Okay, so we want actually the second thing here. Here we go. So what this shows is roughly how many iterations it took for every pixel to get here. If I... If I remove using the result from the pre-pass, there we go. Just had to recompile. This is basically, so it's divided by 100. So white here is 100 plus iterations that it took for every pixel to actually march the objects in some of these scenes. If we go to some different scenes, it's a bit better to see the difference here. But basically, this is really worth it in a lot of these scenes. So this tunnel scene looks like this, just, again, displaying iteration count. And if I then use the pre-pass stuff, you'll see it gets a lot darker, and you also see, like, per tile, or it's based on information per tile. And that darkening is a speed improvement when we actually look at the scene itself. The pre-pass itself, if we look at the profiler, is this tiny blue box over here. It's basically free. And then here, again, there's not too much difference because we're still doing indirect lighting and stuff. In fact, I'll actually remove that just so you can see more that this is more significant. So if you remove all the indirect lighting and some stuff that comes with it, you can see the scene is about 3 to 4 milliseconds, about 4 milliseconds in this case. And if we, that's without the optimization. With the optimization, it goes down to, well, let's see. It goes down to 3 milliseconds a little more stably, down to 2 in some cases. So definitely significant in terms of the primary rays, but again, because this demo did a lot more than just that, it didn't really make too much difference here, but still pretty cool. So yeah, Bloom looks better now. I'll have to save that out into another project. But yeah. And I'll play with this a little bit more. In fact, while I'm still here, let's get some blue stuff in here. I like the blue. I think this is a really good scene to tweak the bloom on. Why don't I just, while I'm here, I'll just add another pass. Just going to copy and paste everything down here. In fact, I'll bring this back up. Even though it's not very exciting. And just all this stuff. You know, these 3s to 4s. A couple things here. This is also going to be 16th res. Before I forget, I'm going to make sure these get called as well. And here we'll change the stuff too. A lot of things here that I need to parameterize, but we don't care. Do we? And it's yelling at me now because I haven't actually created that render target. That's a good little compiler. Telling me what to do. Okay. And the last thing I didn't hook up is I need to actually put that bloom texture into the stuff. Into the shader. And then we'll just do the same thing again. Didn't behave exactly as I expected, but I guess that's because the last one's getting a lot of weight now. Also, what I should do here is just make sure that we're getting this correctly. Yeah, we're not. So I probably messed something up here again, which is okay. This is easy to fix. I bet it's the input that I didn't do right. Downscale pass 4 writes to blur target for 1 and as input. Yeah, that's what I did wrong. We need 3-1 as input. There we go. That's a wide bloom. Now the bloom is taking visibly longer. I think we don't need 4 iterations on all these different Gaussians as well now. So I'll reduce those. Then we can play with that shape again. Except we'll want to actually do the weighted sum. And again, against our original, for example. Well, unfortunately, I actually lost I touched time. Let's see if we can get roughly the same. Yeah, that looks good enough. So here, the newer one still has a better fall off, but we totally get that width again. So that's really nice. In fact, I'm much happier with the second image in this case. That's really great. And none of the parameters to the bloom have changed, just the implementation. So that's also pretty cool. This works so well just as is. the last thing I want to do here, first of all, I'm going to save this. And then what I'm going to do is I'm just going to hold, well, I can't just hold undo because we've changed some of the shaders as well. But let me fork the project like I wanted to do anyway. I'm going to have to copy some files here, but this should be fine. I wanted to do this anyway. So I'm just going to, whoops, that's not the right one. Bloom play. So this is for 29. And I'm even going to open the other rocket file. Just to make sure we're good here. Should be, because everything should be relative to that directory. Although I'm going to close all the tabs in Sublime to make sure I'm not editing the wrong shader files in case I open these again. And then I should just be able to open that other project. And this should work, except again, we've got the wrong time. But that's easy enough to get back to. Is it that? No, not quite. Almost. Perfect. Okay. And what I wanted to test here is that our bloom is, you know, around 0 to 1 milliseconds here, as we expect. And then if I open the other project, bloom stays at, okay, we want to have that full res first of all. Then again, 0 to 1 milliseconds. So from what I can tell, again, that's pretty unscientific. I would want better things to measure the difference here. But we basically made a bloom. Oh, wait. Nope, this is still the modified one. I need to check out that directory again. In the demos repo. Clear that. Check out everything in that directory. So we just have the new bloom play stuff, and then I'll actually I don't need to reopen that, but or I didn't need to close that, but well, that's fine. And then now we should have a more fair comparison. And here the bloom, again, 0 to 1 milliseconds. It does look a little bit faster. Seems like it stays at 0 milliseconds a little bit more. But the fact is, this is way better. Or the new ones looks better. For basically not much loss, and I bet I can adjust that a bit more as well. So I'm pretty satisfied. That's good enough. That's as scientific as I wanted to be today. So I'm pretty happy with that. I'm going to commit that. That looks right. Cool. That's all I wanted to do today, so I'm actually going to go. This went really well. I'm really pleased. Thanks, guys, for hanging out, and I'll see you next time.